This question asked in GATE ECE 2023 1 mark MCQ. In the circuit shown below, P and Q are the inputs. The logical functions realized by the circuit shown in below. So they provided 2:1 marks and two inputs I0 and I1. Let us consider 2:1 marks having two inputs I0 and I1 and one selection line. So the output Y is equal S bar into I0 plus S into I1. So now for given 2:1 marks, the output Y is equal to Q bar. Q is the selection line. Q bar into input I0. So I0 plus Q into I1. So here I0 is 0. Q bar into 0 plus Q into that I1 is the P. So Y is equal to QP. The final answer is A. Y is equal PQ. This question asked in GATE ECE 2022 1 mark MCQ. Consider the 2-bit multiplexer shown in the figure. For output to be the XOR of C and D, the values for A0, A1, A2 and A3 are. They provided 2-bit multiplexer, two selection line C and D, the corresponding outputs. So C is 0, 0, the output is A0. C is 0, 1, the output is A1. 1, 0, output is A2. 1, 1, the output is A3. But in the question they mentioned that output is the XOR of C and D. It is XOR of C and D. Now we know that in XOR the output is 1 when inputs are unequal. If both are 0, then output is 0. So 0, 1, 1, 1, 0, 1, 1, 1, 0. Now A0 is equal to 0, A1 is equal to 1, A2 is equal to 1, A3 is equal to 0. So the option C is correct. This question asked in ECE 2021 2 mark MCQ. The propagation delays of XOR gate, AND gate and multiplexer in the circuit shown in the figure are 4 nanosecond, 2 nanosecond, 1 nanosecond respectively. The propagation delay of XOR is 4 nanosecond and AND gate is 2 nanosecond and mux 1 nanosecond. All the inputs P, Q or S and T are applied simultaneously and held constant. The maximum propagation delay of the circuit is. So we need to find the output, how much time taken by the circuit to get the output Y. So we have two conditions here, when T is equal to 0 or 1. So assume now T is equal to 0. Now we consider T is equal to 0. So what is the output if T is equal to 0? Here 0, it is also 0. That output Y, it depends upon the input of this line. So now this is the output of this AND gates. So inputs are P and Q, the output is PQ. Now if T is equal to 0, this is the path we get. This is the path we get output Y. Now if T is equal to 0, then Y is equal to PQ. So to get this output, how much delay we want? Actually this AND gate is 2 nanosecond delay and this mux is 1 nanosecond delay. To get this output, Y is equal to PQ when T is equal to 0, then 2 nanosecond plus 1 nanosecond. So completely we required 3 nanosecond to get the stable output. Similarly, we need to find the output when T is equal to 1. When T equal to 1, the output Y depends upon this input line. Let us assume like T is equal to 1. The selection line for both muxes are 1. Now if S0 is equal to 1, then Y depends upon this input. So now output of this AND gates. So this, to get this output, we need mux outputs because one of the input of this AND gate is mux output. When T is equal to 1, then output of the max depends upon this line of input, this line. So now this R and S, the output is RS. Now this connected to this output when S naught is equal to 1. Now here the another input of this AND gate is the output of this AND gate. So P and Q. Now this is the PQ. So when T is equal to 1, nothing but the selection line equal to 1, then Y depends upon this input, then Y is equal to PQRS. Now to get this Y equal to PQRS, now the path is like this. Now here to here like this, you need to get. Now to get this output, so this is the AND gate, the propagation delay is a 2 nanosecond, mux 1 nanosecond, and also here 2 nanosecond, mux 1 nanosecond. Similarly, to get this PQ, we require 2 nanoseconds. Clear? So what is the maximum? They are asking maximum propagation delay. So maximum delay. So now here one AND gate, to get this Y is equal to PQRS, we need 2 nanosecond plus mux 1 nanosecond. Similarly, this AND gate 2 nanosecond and mux 1 nanosecond. So completely, so here to 6 nanosecond. To get the output Y is equal to PQRS, we required 6 nanoseconds to get a stable output. This question asked in ECE 2017, set to 1 mark question MCQ. So we need to find the output F. So now assume that output of mux 1 is F1. So F1 is equal to X bar into Y plus X into another input 0. Now F1 is equal to X bar Y plus X into 0. Now F1 is equal to X bar Y. The output of mux 2 F is equal to Z bar into this input F1 plus Z into this input. So this is the F1 bar. Now Z bar, F1 nothing but X bar Y, Z into F1 bar and X bar Y whole bar. So we can write this X bar Y whole bar as a X bar plus Y bar. We can write X plus Y bar. So X bar Y Z bar plus Z into X plus Y bar. So X bar Y Z bar X into Z plus Y bar Z. The final answer F is equal to X bar Z bar plus XZ Y bar Z. X bar Y Z bar XZ Y bar Z.